So today we're continuing along. We skipped 5.19. We're going directly to 5.20, Module 5, Lesson 20. And today we're really going to be taking a closer look on how we can classify or sort polygons into a hierarchy. Hierarchy means different tiers or different levels. Remember that picture you drew in your notebook yesterday where it started with quadrilaterals and then went to trapezoids and parallelograms and things like that? That's a hierarchy. What's the biggest category? What was the smallest category? Square, yeah. So that's a hierarchy when it goes from a big category to a small category. We're going to sort and classify polygons into those categories. So a kite is another special kind of quadrilateral, okay? And its attributes, its properties is that it has two pairs of congruent sides, just like what other polygon has two pairs of congruent sides? Everyone? Oh, it does, yeah. Anything else? A special type of parallelogram that has 90-degree angles called a? Rectangle or square, yeah. But the difference is in a parallelogram, are the congruent sides next to each other? No. They are what? They're parallel, but they are opposite from each other. Do you see that? Yeah. Right? But in a kite, the two congruent sides are adjacent. What does adjacent mean again? Point to the person you're adjacent to. Adjacent means next to. So in a kite, the two congruent sides are next to each other. You see that? Okay. So unlike a parallelogram, sorry, I forgot that when I was writing this. Unlike a parallelogram, okay, or a square or something like that, the adjacent sides are not opposite from one another. They are next to each other. The congruent sides, I should say, are not opposite from each other. They are next to each other. Do you see the difference? Take a minute to draw in your math notebook and write this definition down. On this hierarchy chart we had yesterday, the kite is drawn like this. You can see that it's always inside the quadrilateral section. Do you see that? Okay. But it's sometimes, this part of it is sometimes only a quadrilateral. But this part of it is a kite and a what? Parallelogram. And a trapezoid. Do you see that? Sometimes they can be considered squares as well. Okay, so take a look at the hierarchy you drew the other day and add in the kite. In your lesson 20 problem set, the first set of directions says true or false. So you have to first decide if it's true or false. And then if it's false, you have to rewrite it to make it true. Okay? So think to yourself. Question A says all trapezoids are quadrilaterals. Is that true or false? Are all trapezoids also considered quadrilaterals? Yes, it's true. So go ahead and mark true. And the reason why that's true is because how many sides do you have to have if you are a trapezoid? 4. And if you have 4 sides, 4 vertices, and 4 angles, you are automatically also a trapezoid. So just mark true. All parallelograms are rhombuses. Is that true or false? False. False. So go ahead and mark false. But it says if it's false, you need to rewrite it to make it true. So how could I rewrite this sentence to make it true? All parallelograms are rhombuses. Ani? Some. So if I rewrite some parallelograms are rhombuses, then that would be true. Because what kind of parallelograms are also rhombuses? Parallelograms that have 4 congruent sides. And that's not all parallelograms, it's just some parallelograms. Do you see how this works? Okay, let's try the next one. All squares are also trapezoids. Is that true or false? True. True, very good. Because do all squares have at least one set of parallel sides? Yeah. Very good, that makes it true. Okay, next. All rectangles are squares. True or false? False. Very good. How could I rewrite that sentence to make it true? Rohan? Some rectangles are squares. Because which kinds of rectangles are squares? The rectangles that have 4 congruent sides. Very good. And that's only some of them. We can see here, it tells you that figure A, B, C, D, that's how you name figures, A, B, C, D, so you know we're talking about this guy over here, is a trapezoid. Do you agree? Yes. What makes it a trapezoid? It has one pair of Parallel lines. Okay. It also gives us some information. It tells us that angle ABC, this one right here, is 40 degrees. And we know that angle BCD is what? 90 degrees. Okay. Now, it's missing some information too, and it wants us to find the measurements listed below. We know that angle A is this one right here. How do we know how much degrees or what the measurement of angle A is? Well, we learned that in a trapezoid, there's pairs of angles, yes? And one pair always touches opposite parallel sides. So this 40 degrees is touching this parallel side right here, so its pair must touch this one. Do you agree? So angle A is the pair of angle B. Do you see that? So what do we know about pairs of angles in trapezoids? They add up to 180 degrees. That means 40, which is angle A, plus something, plus angle B is 40 degrees. If I add that to angle A, it's going to equal to 180 degrees. So what must angle A be? Everyone? Very good. Do you see how we can use the information to fill it in like that? Okay. What about angle D? Well, we know that there's a pair again. Angle C, oops, that's the wrong pen. Angle C is touching this parallel line right here. So what angle is its pair? Angle. What's the measure of angle C? Oh, sorry, forgot to switch over. Okay, so 90 degrees plus the missing angle, angle D, is going to add up to 180 degrees. So what is angle D? 90 degrees. Very good. Okay. Now, you could look at this picture and say, oh, this looks like it's a 90-degree angle. But can you guess that or assume that just based on what it looks like? No, that's very dangerous. Make sure you think about pairs like that. Okay. Now, the next question says, what other names does this figure have? Sure, it's a trapezoid, but what else could I call it? Could I call it a parallelogram? No. What else could I call it? Subhan? Quadrilateral. That's the only one. Only other name. But sometimes could figures have lots of different names? Yeah. So when you're thinking about what other names it could have, oh, it could be called a polygon, right? Yeah, so let's write that. Think about the work we just did with the posters and think about those hierarchies to know what other names it could have, okay? I highly recommend that you do the rest of these practice problems, the rest of number 1 and the rest of number 2. Why is that? Why do you think? Why do you think? Sanatan?
It's important that we do these at home because otherwise we won't know how to study for the weekly check-in
You got it.
Tomorrow and the Module 5 test on
Yeah.
Wednesday.
These skills, asking true or false and rewriting the statement, and then also finding missing angles, like in number 2, those are the skills that you are going to be tested on tomorrow in your weekly check-in and also next Wednesday on your Module 5 test. Make sense? Very good.